Alright guys, so in this video, I'm going to answer this problem right here. It says, if alpha and beta are the roots of the function x squared minus 5x plus 3 is equal to 0, form the equation with roots alpha times alpha minus 1 and beta times beta minus 1. Okay, so we have x squared minus 5x plus 3 is equal to 0. And so we know that for any quadratic function, the sum of the roots, that is alpha plus beta, sum of my roots, I have one root alpha, one root beta, sum of my roots is negative b over a. For a quadratic function in standard form, ax squared plus bx plus c equals 0. And so in our case, minus b over a is minus negative 5 all over 1. And that is 5. Double negative is new positive, positive 5. So that's the sum of my roots. The sum of my roots is 5. Alpha beta, the product of my roots, is c over a. For us, our c value is 3. And again, our a value is 1. And so 3 over 1, that's 3. And so I have that the product of my roots is 3. So the sum, alpha plus beta, is 5, and the product, alpha beta, is 3. All right, we want to form the equation then that has the roots R1, alpha on alpha minus 1, and R2 is beta on beta minus 1. Those are the two roots of the function we want to form. We know that if we know the sum of the roots and we know the product of the roots, we can then form that function. So that's what we're going to do. We're going to find the sum of these roots, then we're going to find the product of these roots. We're going to find the actual value of the sum and the actual value of the product. Okay, so to start, I think I'll start by distributing out my parentheses in both of my roots. So I have alpha on alpha minus 1, so that is alpha squared minus alpha. And R2 is beta squared minus beta. And now I'm going to I'll start with the sum of my roots. For shorthand, I'll write SOR, that's the sum of the roots. So that is R1 plus R2. Well, R1 plus R2 is therefore alpha squared minus alpha plus beta squared minus beta. So I can gather that up. I have alpha squared plus beta squared minus, I have minus alpha minus beta. What I'm going to do is I'm going to factor out from minus alpha and minus beta a minus sign. So that will be minus on alpha plus beta. And so I have alpha squared plus beta squared minus parentheses alpha plus beta. The alpha squared plus beta squared, we know that that is equal to alpha plus beta all squared minus 2 alpha beta. And so I can replace alpha squared plus beta squared with alpha plus beta squared minus 2 alpha beta. And again, I have minus parentheses alpha plus beta. And now it's great because I now know all of these values. I know the value of alpha plus beta and I know the value of alpha beta. So I can actually just input those values. And then this will become alpha plus beta, I remind myself, is 5 and alpha beta is 3. So this becomes 5, alpha plus beta squared is 5 squared, minus 2 times alpha beta is 3, minus alpha plus beta is minus 5. I can work this out. I get 25 minus 6 minus 5, and that is 14. And so I find that the sum of my roots is 14. That is the sum of my roots. All right. Now I have to find the product of my roots. So I'll put that down here. Product of my roots, just for shorthand, POR. That is, I want R1 times R2. So that is, I have alpha squared minus alpha times beta squared minus beta. So I have to multiply these two together. They're binomials, and so I'm going to FOIL them out. I'm going to have first alpha squared times beta squared. That is alpha squared beta squared. Then I have alpha squared times negative beta. That is a positive times a negative is a negative, negative alpha squared beta. Now I have negative alpha times beta squared. That is negative alpha beta squared. And finally, negative alpha times negative beta. That is positive, double negative, positive alpha beta. All right. In order to get this into an alpha plus beta and an alpha beta, and just alpha beta terms, I'm going to have to adjust this a little bit. I'm going to have to do a little bit of factoring. So alpha squared beta squared, well, that's just alpha beta squared, right? Alpha squared beta squared is simply alpha beta squared. And of course, I know alpha beta. Minus alpha squared beta and minus alpha beta squared. What I'm going to do there is I can factor out an alpha beta. And so that's what I'm going to do. I'm going to factor out, in fact, I'm going to factor out negative alpha beta out of those two middle terms. So I'm going to factor out minus alpha beta. And if I do that, well, if I factor out negative alpha beta out of negative alpha squared beta, I'm going to be left with an alpha. And if I factor out a negative alpha beta out of negative alpha beta squared, I'm going to be left with beta plus beta. And then, of course, I have a plus alpha beta. And again, I now have my product of my roots in terms of purely alpha plus beta and alpha beta. And I know those values. Alpha beta is 3, so this becomes 3 squared, minus alpha beta is 3 times alpha plus beta, which is 5, plus alpha beta, which is 3. 3 squared is 9, minus 3 times 5 is 15, plus 3. And so if I work that out, 9 plus 3 is 12. 12 minus 15 is negative 3. And that is the product of my roots. The product of my roots is negative 3. And it remains then for me to just fill it in. I know that a quadratic can be written in the form of x squared minus the sum of the roots times x plus the product of the roots equal to 0. And so I have x squared minus the sum of my roots is 14. So that's minus 14x plus the product of my roots, that's plus negative 3. That's negative 3. And that is my solution. X squared minus 14x minus 3 is the function that has roots alpha on alpha minus 1 and beta on beta minus 1. That's how we go about it.